Hey guys, it's me Fox. As you can see, it's a war zone here. My machine is on the pallet jack, but I managed to record something when it was up. Today's video is gonna be about Submicron Precision Z axis. I've been asked for plans, so I made a website where you can download upgraded plans of my granite CNC machine. If you download and hit the yellow button, I will really appreciate your support.
Link in the video description.
I would like to start this video from cutting a clamp for the bowl screw. I thought it looks pretty cool without the coolant. Here we have some real-time footage. It produces quite a substantial amount of chips. I'm cutting 10mm pass, and I believe it's 2mm side cut. And I speed it up a bit. And I had to use compressed air, but it couldn't keep up. And now the second pass. Again, substantial amount of chips. And they're gonna speed it up. Contour. Yeah, it looks like a hedgehog. And now some holes. Those gonna be 20 something millimeters deep. Done. And now I will move to a Z plate, the base plate of the Z. So again, same 10mm deep, 2mm side cut. And here I believe I had the problem with the filter. It got clogged and I lost the pressure of the coolant. At the beginning I thought it's just the roughness of the vacuum plate, but yeah, it turns out it was a coolant. And here I'm doing a pocket with the 1mm side cut just to make it flatter. Because of the Z-axis tram, it will be, on average, much flatter than with the less amount of passes. And here I'm doing the other side, the pocket for the bowl screw. It's done. So it's all cut. So one plate and then the other plate. Here I just left it adaptive. Couldn't be bothered finishing it up. There was no point. And here is the top. And that one has undercut for the bowl screw mount and the bowl screw. There is, I think, like a millimeter in the design clearance from the bowl screw to that carving, or maybe 1.5. Don't really remember. For me, the most important part was to have the same thickness here and here. So when I was setting it up in the CNC, I was probing corners to set it up on vacuum plate. I spent some time to make it right, and I was probing 4 corners and somewhere in between. And because this whole thing is very flat, so I was probing from the top, not from the bottom of the vacuum plate. In this way I was sure I will have exactly same distance from the top to that cut. And now let's see how consistent it is. So between that thickness here and here, because it was identical, so that thickness should be pretty much identical as well. So it's 0. So I'm gonna measure it at the top of the notch and on the other side. Okay, 15. And here, oh, got on the screw, 15, thereabout. And on the other side, moment of truth, 15. And Jesus, around 15. Okay, pretty cool. Let's do some more precise measurement. Because I don't have such a small micrometer, I'm gonna use the standard 50 millimeter, and I'm gonna put it in here. Here or here? I guess I can put it here. So I'm gonna measure it in the center somewhere. I have to get the camera closer. Give me a sec. It should be in focus. So here we have a line under the zero, I think. One line, it's 10 microns. So it appears like to be 2 microns under 15 millimeters. I'm gonna rotate that thing and see the other side. And let's see if I get it in the same spot. Okay. It's kind of tricky to wiggle this thing in place. Okay, it's clicking. Okay, and here is a line over, like another 2 microns. I'm guessing it's within 4 microns? Shit, that's close. Okay, not bad. That thickness, to me, it was very important for the travel of the screw. Let me show. Okay, here goes the bolt screw. And the rails, one here, the other here. The rails are on a very flat surface here, and I had to recess the center to fit the bolt screw, and I was really interested to have it super flat, so when the bolt screw travels forward and backward, it doesn't go up, or because when we put that plate, right, that plate in here and bolt it in, and then you bolt the bolt screw to the plate. When that plate goes, you know, forward and backward, it might find a spot where that bolt screw it wants to go up, and then deep down and up or whatever, if you have irregularities in here. I didn't want it to have any of that. I wanted to run as true as is possible, so I don't have like a spindle at the end, like at different heights, changing the angle. Yeah, and basically I wanted to have it like dead straight in any orientation. While the machine was cutting, I thought, you know, I had to do something, so I honed the rails over the granite surface plate. So, like, you just get the rail and you just rub it against the surface plate. You can use the stone or whatever. To take the burr off, I had the one burr in here when it was dinged. Now it's very nice and flat, and I guess you can see the shine. The same I have to do with sliding blocks. Oh yeah, that doesn't sound good. I'm not riding on a screw or anything. Let me see. You see, it's marking the granite plate. So I think there is another ding in here and here. Okay, I have to get the stone. It's a very rough stone. And yeah, I'll try to take the high spots. It would be good if the stone is flat. Let's see now. Better, but there is still something. Yeah, it's exactly here. Yeah, that high spot, it's precisely in here. And I'm trying to avoid any high spots. Everything has to be freaking precise. And here. Okay, let's see now. Oh, much better. Much better. Okay, so I can see it quite clearly now. So I'm not sure if you can. On the camera I think it looks kind of weird. So the shiny spots, like that place in here, is what I've done in this with the stone. But then I can see those darker patches around. So that's where the surface plate got it. And I think it's even here flat, so that's good. Gonna see the other one. Jesus, again something. Where is it this time? I think in the center here and here. Okay. I'm gonna find this flat. Okay, much better. No, oh, much better. Much better. There it was. You can see it here. Here is shinier. It feels like it's gliding everywhere. Almost. Obviously it's not, but I think my aluminum plate is flatter than this. And I think it is. So now you can see it very easy. Gonna get the highlight, because now the highlights actually what got rubbed. So it's here and here. The center barely is touching. It's not crooked, but it's not perfectly flat either. I'm gonna bolt it in and do some tests. Here I have a dial indicator on the base, and I'm gonna measure the travel on this plate. So we have a base, we have a top on which the rails are mounted. I really wanted to have that distance never changing, because when you lower the spindle, You don't want that thing to go crooked because then you cannot trim it. Let's see how it looks. I'm gonna put it in. Okay. And let's take a look. If you're wondering if it's working, see? It's working. So I think that should be pretty good. And what else? Maybe we can see the top surface. The top surface is not as important because I'm gonna bolt the spindle into those two places. As long the top plate travels parallel to the bottom plate, that's all of what I need. The top surface of this plate could be, you know, rough as a moon, but it won't affect the precision, only the place where you mount the spindle. Let's see the top. I have this whole assembly on the surface plate, and now I'm gonna go swipe. So let's see what it sees. 0 wobble. I think it was the surface plate. Yeah, here it looks amazingly zeroed. Okay, and lift it up and put it down. Lift it up, put it down. And it's not sticky or anything. It's just flat. I have anodized the plate, the first one. The second one is cooking. So I stoned all the surfaces for maximum flatness. And now I'm gonna put it in. Is it going that way or that way? Because one way it's a bit shorter than the other way. Now I'm gonna put a screw. Yeah, I flattened all the surfaces on the stone. So here you can see the contact points. Here it had a pinch on the corner. I don't know why, but it had. So it's good to check it before you install the thing because it might be crooked. Okay, more screws. So now I will undo the screws and see if I have a bit of a wiggle room just in case. Oh, yep. That's good. So it means I can do some micro adjustments. I hope it will work as well as it looks. Here you can see the setup. I'm making that reference rail straight, and that's my reference. To line it up, I'm using two 10mm old end mills. You know, the diameter of this shank is very accurate. It doesn't even have to be that accurate. You just need to have some reference from which you're gonna be measuring. And that edge of the Z-axis is not precision milled, it's just milled, so I cannot rely on it. So that's why I'm using 2 pins here and here, and then I'm using a granite square. So I have my reference line and I have my rail with the dial indicator attached to one of the carriages. So I'm referencing the straightness of this rail from the granite block. And as you can see, I managed to do a pretty good job. Let's take a closer look. So my dial indicator is working, right? Both ways. And now I'm gonna move it down. Oh, it's pretty solid. And now I have to, run this rail truishly to this one. So that's gonna be interesting. Which edge? That's the precision ground edge, so it should be fine. Oh, and that rail goes. And I bolted the rail, put the granite square edge, and now I'm gonna show you how those are running. And yeah, it's within just a few microns. It took me quite a while, but I finally adjusted the screw. To adjust it, I bolt, few screws here and a few screws here. And I was moving bolt screw back and forth, and I was, measuring a nut and adjusting it left and right, left and right. Because each time you bolt the screws, you bend the bolt screw. Because you adjust one way and then, that thing is off. So that thing took me around like 4 hours to get it right, because I also had to adjust the servo. That coupler, if the servo is slow, then the bolt screw becomes bent. So it has to be as dead center as is possible with the screw. So it's very, very tricky to make it precise. The bolt screw had 10 micron of wobble, and that whole thing added also around 10. So I'm like within 20 microns of wobble. So I want to show you that. Here it bounces from 0 to 20. 0, 20, yep, precisely. So I'm measuring on the side. I measure already the top, and the top is pretty bang on. But if you do your one and you're not sure if the position here and here versus the blocks is level, it's good to check. And here you can see it's 13 to 15 microns. I was hoping to get it better. You know, I've done my plates, aligned the rails, you know, better than the screw is, and it's a ground brand new screw. You know, when you're trying to make something so precise, 10 microns is a lot, and it feels like a failure. So I don't know, maybe somehow one day I will get some more precise screw, but I'm not entirely sure if it's important, because those carriages should keep it steady. You know, 10 microns or 20, it's not that much of a wobble, so the forces won't be big. Yeah, so I'm gonna attach the top plate now. In the meantime, I made a top plate. I added the skirting all around to keep the chips away, and slightly stiffen the Z plate. On the bottom it looks like this. It's a 3mm flat bar, which I wrapped around and, you know, anodized, drilled, and so on. And now I'm gonna attach that thing. Okay. I'm tightening the pattern of the screws because when I milled the channel in the middle, that thing bowed out like this, and the bottom one bowed the other way. So by screwing that thing together, I'm gonna make it, you know, from that shape to more straight shape. But that thing, it's not terribly critical because we have everything parallel and flat, except that bow, which it's not really critical because just gonna put the preload on the carriages. And here I have ball screw clamp, which I milled, and I just have to, you know, put it in at the right angle to meet with the plate underneath. Okay, now gets in. And actually I should have a dial indicator in before I'm gonna put it in. That's kind of funny how like every screw does something to the dial indicator. Now it moved back 5. Okay, more screws. Now let's see if it's gonna change. It moved down by 10 microns. It looks like the needle stayed on 10 microns minus. So it means that I'm actually pushing it down by 1/8 of a hair. That's acceptable. So I hope you like it. Whoopsie. I hope whatever you have seen in this video was helpful. I shortened it as much as I could. I think I got like 2 terabytes of footage, but I managed to just make it 25 minutes out of it, or something about. The next video I'm gonna be doing the sides for the gantry, so please stay tuned and be back next week, I think. I still have to, you know, fight with the mess I've done here. I'm trying to bring it back to life as fast as I can, so the shop is operational. Until then, see you next time.